Myself, I am Dr. P. Reddy Prasad, Associate Professor, Department of Chemistry, Institute of Aeronautical Engineering, Hyderabad. Now I am going to discuss Engineering Chemistry syllabus, Electrochemistry and Corrosion. This is Module 1. Now I can go to topic batteries. So in the presentation, there are some important contents is there. Now today I'm going to discuss primary cells and secondary cells and differences of primary and secondary cells. So the content of this module, presentation, primary cells, primary batteries, secondary batteries, and the differences of primary and secondary batteries. First of all, the history of battery. If you look at the history of battery, so 18th century to 1999, so there are a lot of evaluations is there in battery history. So in 18th century, the voltaic, he was first invented the battery. That battery is silver zinc battery. Then after that, 1836, Daniel cell was invented. It is the copper zinc electrode consists of electrochemical cell. That is called as a voltaic cell. In 1859, Planté, he was invented rechargeable battery. That is lead acid battery, lead acid cell. In 1868, Leclanche, he was invented carbon zinc battery. It is a one type of dry battery. In 1868, Leclanche, that's the reason we can call it as a Leclanche battery. That is called as a dry battery. In 1888, so Gassner, he was invented. So one of the battery, it was studied especially in carbon zinc dry cells, dry batteries. And in 1898, the commercial flashlight was invented. And 1899, the Jungner, he was proposed one of the battery, he was invented nickel cadmium battery. This nickel cadmium battery is a secondary type of battery. In 1946, Newman, he was invented one battery. That battery is a sealed nickel cadmium battery. This is one of the revolution in the nickel cadmium battery. He was prohibited the leakage of electrolyte in that battery. And in 1960s, alkaline and rechargeable batteries more evaluated in that area, particular time. And 1970s, and a lithium sealed lead acid battery proposed. And 1990s, nickel metal hydride battery is generated. And 1991, lithium ion battery, we know that nowadays the lithium ion battery, how much importance. So the invented is happened in 1991, this lithium ion battery. In 1992, rechargeable alkaline batteries is invented. So alkaline metals is a more one of the versatile metals in battery history. And 1999, lithium ion polymer batteries are invented. This is one of the revolution in battery history. So you look at the history of battery, the first true battery, it was invented by the Italian physicist Alessandro Volta in 18th century. Volta is stacked discs of copper and zinc separated by the cloth soaked in salt water. It was developed one battery, that is a voltaic battery. Voltaic battery is nothing but Daniel cell, Daniel cell. That electrochemical cell, they're interconnected, then they converted to battery. This is the history of battery. Now we will go to discuss electrochemical cells and battery. What is battery? What is battery? Battery, it is a device. Battery, it is a device which is the number of electrochemical cells. We know that electrochemicals is cells is consist of anode and cathode and electrolyte. This number of electrochemical cells are connected in a series, then that battery, it's converted to the electrochemical cell battery. So a battery is a device in which number of electrochemical cells are connected in a series, that is called as a battery. In the battery, the transferred chemical energy into electrical energy. In the battery, we know that it is an electrical energy generated device. There is another definition is there. There are two or more electrochemical cell. The two or more electrochemical cell are electrically interconnected, the each of which containing two electrodes, and an electrolyte is called as a battery. When the electrochemical cells, the two or more electrochemical cells are interconnected, that the device is called as a battery. Batteries, classification of batteries. Batteries, we are classified two types. That is primary battery and secondary battery. That is called as because this is the electrochemical cell. So electrochemical cell, we are interconnected. Then the device, that modified electrochemical cell series, it's act as a battery. That's why we are called as a cells, primary cells and secondary cells. The batteries are classified two types, that is primary batteries and secondary batteries. The battery's potential, it depends on the how many number of electrochemical cells we are going to interconnected in the battery. So each electrochemical cell having the specific potential, then when we are interconnected more than two or three, so that the potential, the total potential is equal to battery potential. Therefore, batteries are commercial electrochemical cells. Batteries are commercial electrochemical cells. The battery's voltage, output voltage and current ratings are determined by it depends on this phenomena. That is, elements, what type of elements used in the electrode. We know that in electrochemical cell, there is two electrodes is present. The two electrodes, what type of electrodes we are used. And what are the size we are developed in the electrochemical cell. How much size we are using. Size of the electrode also is one of the important factor to generate the potential. The size of the electrode and the nature of the electrode and the type of electrolyte. Which type of electrolyte, which is strong electrolyte or weak electrolyte, what type of electrolyte we are using in the electrochemical cell. It is also one of the important factor to develop the potential in battery. So these are the causes of the developed potential, how much voltage is generated in the battery. So elements used in the electrode, for the electrode, what type of electrodes we are used, and the size of the electrode and type of the electrolyte. These are the important factors to develop the output of the potential in the battery. And primary battery. We know that the batteries were classified two types. The first one is the primary battery, that is the primary cell, and the second one is the secondary battery, that is the secondary cells. What is a primary battery? Primary battery or primary cell, which battery we cannot easily recharge after usage, after one use. That battery we are called as a primary cell or primary battery. So because of that, after usage, we need to discard that battery. So that means then the battery in the electrochemical cell, the interconnected electrochemical cell, is only one redox reaction is occurring. Only forward reaction is happened in the electrochemical cell. So after one reaction, the battery is going to dead. That's why we are using which batteries we are using it is not easily possible to recharge. That batteries we are considered as a primary battery or primary cell. So the battery, especially in the primary batteries, the chemical reaction is irreversible reaction. It is not a reversible reaction. The A, it's not going to come back to the A. The reactant is once formed to the product, then it cannot come to the A reactant. That is, the chemical reaction is irreversible reaction. Irreversible reaction, that means the battery cannot use number of times. There is a possible only one time. That battery we are considered as a primary battery. Here, the chemical energy is converted to electrical energy. In the primary battery also, because this also spontaneous redox reaction is happened, in the chemical energy is converted to electrical energy. So that is, we know that any electrochemical cell, it's working on this principle. But electrolytic cell, it's working on the chemical energy, utilize the electrical energy, is going to studied the chemical energy. But electrochemical cell is going to convert electrical energy, chemical energy is converted to electrical energy. It cannot be recharged because the primary batteries we are not going to recharge. And internal resistance is very high, due to the reason the potential is going to down. Once uses the battery, so or if you stable the battery, then the battery due to the internal resistance is very high. Due to that, the battery potential is going to decrease and can supply weak currents only. The primary batteries can supply weak current, but this battery is very lightweight and very economic also. Battery is a lightweight, so economic also. That's why still we are using this battery, like primary batteries. The best example of primary battery, that is a lithium battery, lithium cell. Lithium battery is also there. That is a non-rechargeable battery. And dry cell and mercury battery, mercury cell. These are the examples of primary cell or primary battery. Now we are going to discuss one of the example of primary battery. That is dry cell or Leclanche cell, Leclanche battery. Dry cell or Leclanche battery. If you look at that picture of dry cell, we know that component in the dry cell. Why we are called as a dry cell? Because no electrolyte we are going to use in the battery. So that's why we are called as a dry cell or Leclanche cell. Leclanche is a scientist. He was invented this battery. This is a dry battery. This is the best example of primary battery. This is a non-rechargeable battery. In the battery, they used a zinc container. That zinc container, it's act as a anode. The zinc container, it act as a anode. In this battery, the zinc container, this was the zinc container. The zinc container is act as it is a metallic frame. The zinc container is act as a anode in the dry cell battery. The center, they used a graphite rod. There is a carbon rod. We know that graphite, carbon rod. It is placed in the center. It acts as a cathode. So this zinc rod is act as an anode. The zinc plate is act as an anode. And the graphite rod is act as a cathode. The electrolyte is in between the cathode and anode. They are using some paste. The paste is ammonium chloride and zinc chloride and carbon paste. Ammonium chloride and zinc chloride and manganese oxide they're using and mixed with carbon. That paste is act as a electrolyte. They are placed in between the cathode and anode. In between the cathode and in between the anode, there is a paste is there. That is the yellow color we are represented. That yellow color is the electrolyte. That is the dry electrolyte. That electrolyte, mainly the component is manganese oxide, ammonium chloride, and carbon. These are the components is present in the dry cell. This component, this paste is act as a electrolyte in the dry cell. In the dry cell, so in the Leclanche cell, so zinc is act as an anode, zinc plate is act as an anode, and graphite is act as a cathode, and electrolyte we are placed in between the anode and cathode, that is manganese oxide and ammonium chloride and carbon. There is a paste we are using as electrolyte. This is a dry, that's why we are called as a dry cell. The dry cell, because the absence of any type of liquid phase. There is no liquid phase is present in the dry cell. So that's why we are called as a, this is the dry cell. Leclanche battery is a dry cell. Even the electrolyte also, ammonium chloride and zinc chloride and manganese oxide, and they mix it with starch or carbon material, and they make the paste, the thick paste, and which that paste we are used as electrolyte, because to leaching, to avoid the leaching, to prevent the leaching, we are using this type of battery. This is one of the dry cell battery, electrolyte. So the graphite rod is fitted with the metal cap, the top of the battery, they fitted with the metal cap, and the cylinder is sealed with the top with the pitch. So is one of the advantage to connected with the battery to positive and negative charge, positive and negative charge, negative sign. And if you look at that electrochemical reaction in the primary battery, primary cell, at anode, it acts as anode, as a zinc is act as anode. That anode, so which is consist of hydroxide ions from manganese hydroxide, manganese chloride, hydroxide ions. So to gain that hydroxide ions, it's converted to zinc oxide. This zinc oxide, the formation of zinc oxide, it's going to release 2 electrons. At anodic reaction, so the oxidation takes place, at anode oxidation takes place. Zinc is undergoes to oxidation. Zinc is undergoes to oxidation. Due to the oxidation, the electrons will be released. That electrons is equal to 2 electrons. In cathodic reaction, there is a reduction that takes place. The manganese oxide, they gain the electrons at the presence of cathode. The cathode, which is the cathode? Cathode is graphite rod is act as a cathode in the dry cell. At the presence of cathode, the manganese oxide, which is present in the electrolyte, that gains the electrons, 2 electrons, is converted to manganese hydroxide. Manganese hydroxide. And again, the 2 OH minus ions will be released, then utilized to continuous the reaction, the oxidation reaction. So this is the cathodic reaction. Manganese oxide to gain the electrons is converted to manganese hydroxide. This is the cell overall reaction. So overall reaction. So zinc and manganese oxide gives us to zinc oxide. This is the product zinc oxide and manganese hydroxide. The 2 OH minus, 2 OH minus ions. And there is a 1 H2O, another H2O. We cancel the 1 H2O, then we are getting 1 H2O. So zinc, this is the overall reaction, zinc. So manganese oxide in the presence of water molecule, and is going to zinc oxide plus manganese hydroxide. The potential usually up to 1.5 volts. The cell potential, they usually up to 1.5 volts. The cell potential up to 1.5 volts. So this is the dry cell. Dry cell electrochemical reaction. How the electrochemical reaction is happened in the dry cell. In the dry cell, So anode is a zinc and the cathode is the graphite. So zinc is undergoes to oxidation reaction, and which is we are used as electrolyte. Manganese oxide is undergoes to the reduction at the cathode electrode. I mean graphite at graphite electrode. Due to the chemical reaction, only forward reaction will happen. Due to the chemical reaction, we are getting the potential. That potential is equal to up to 1.5 volts. This is the primary battery example. The example of primary battery, that is a Leclanche battery, dry cell. Now we are going to discuss secondary batteries and what is the applications of primary batteries. What are the applications of primary batteries? Usually, the voltage range of the primary batteries, that is 1.25 volts to 1.50 volts. Usually, that depends on the electrolyte, depends on the anode, and depends on the cathode and the size of the electrode. So the battery is going to produce the potential. So usually the primary battery's potential range is 1.25 volts to 1.50 volts. Primary cells, so still we are using different applications, either torches and radios and transistors and hearing aids and pacemakers, watches, the simple electronic devices, all electronic devices, we are utilizing these primary batteries because the primary batteries are very economic battery and lightweight also. That's the reason still we are using these primary batteries in very number of applications. And there are some limitations is there in primary batteries because these batteries not have long life. We need to use one time. We have to discard this battery after usage because the electrochemical reaction is only forward reaction is happened. Because the acidic ammonium chloride corrodes the container even when the cell is not in use. The cell, I mean battery, if you not use, then which is the present in the electrolyte, the ammonium chloride, the acidic ammonium chloride, the acidic media to go to, I mean to corrode the metal, a zinc metal. So that's the reason. So the battery, the lifelong and the long life period is not going to uses. And when current is rapidly down from the cell, it suddenly is going to down the cell because voltage is going to drop due to the building of the production on the electrodes. Voltage drop takes place due to the building of production on the electrodes. These are the limitations of primary batteries. And secondary battery, secondary cells. The which battery is a rechargeable batteries? Those batteries we are considered as a secondary batteries, secondary generated batteries. The secondary batteries are also called as a rechargeable batteries. The secondary batteries also called as a rechargeable batteries. Because these batteries can used and recharges simultaneously. We can use the battery simultaneously, we can recharge the battery. So that is the advantage of secondary battery. Because we are using in the battery the electrode or other materials, that is very active materials. In the presence of active discharging state. So active materials, active semiconductor materials we are used in the battery. So that's the reason the battery is work on so rechargeable capacity. Rechargeable batteries are recharged by applying the electric current, which reverses the chemical reaction that occur during the discharge. The charges are the device which supply the required current. We are supplying the required current, then again the chemical reaction is happened. So that's why if you see that, look at the picture, there is anode and cathode is there, discharging and charging capacity is simultaneously happened in the battery, secondary battery. Because we are using the electrolyte and electrodes are very active materials. And the chemical reaction is a reversible reaction in the secondary battery. In the primary battery, that chemical reaction is irreversible chemical reaction, but here the chemical reaction is a reversible chemical reaction. The chemical energy is converted to electrical energy during the energy supply, and the electrical energy is converted to chemical energy during charging time. So simultaneously, it's going to convert chemical energy to electrical energy. Chemical energy is going to electrical energy, and electrical energy is going to convert it to chemical energy. The presence of charging and non-charging time. And it can be recharged. Due to that reason, we can use this battery number of times after usage, recharge. And the internal resistance is very low. Comparatively primary battery, the internal resistance is very low. Can supply weak and high currents, this battery. This battery, when we made with active semiconductor, active materials, then battery, it can supply weak and high currents. But this battery, it's look like very heavily, and is also, price also very costly. So that is another phenomena. And the battery, the best example of secondary battery, that is a lead acid battery and a nickel iron battery, nickel cadmium battery. These are the examples of secondary battery. Secondary cells. We'll go for a discussion the secondary batteries. So the best example of secondary battery, that is a nickel cadmium battery. We take the example of nickel cadmium battery. Nickel cadmium batteries, it consists of nickel plate. That nickel plate is act as it's a green color, that is a nickel plate. The nickel plate is act as a cathode, and a cadmium plate, that brown color, gray color plate, that is cadmium plate. That cadmium plate is act as a anode. And in this battery, nickel cadmium battery, the electrolyte is potassium hydroxide. We are using as a electrolyte. Potassium hydroxide we are using as a electrolyte. In that battery, the positive and the negative plates, which are prevented from the shorting, electrical shorting, by the separator we are using, are rolled together. The plates are rolled together and put into the in the case. We have separated that metal rods. So the roll is a jelly roll design. We have made the jelly roll design and allows the nickel cadmium to deliver much more current than similar sized alkaline battery. For producing high density of current, so we shaped the battery, that is the anode cathode, that is the jelly roll design. So this jelly roll design to allows the high current, high potential, because for preventing the shorting of current production, electrochemical reaction. And what is the advantage? The potential from that nickel cadmium battery, it always produces the 1.2 volts to 1.25 volts. The nickel cadmium battery is a rechargeable battery. This is a secondary battery. The battery is going to produce the voltage. The potential is 1.2 volts to 1.25 volts. When properly treated, a nickel cadmium battery can be recharged around 1,000 times. We can use this battery 1,000 recycling capacity is there. 1,000 recharging capacity is there. And the cadmium is a toxic heavy metal. So nickel cadmium battery should never be opened. we are not going to open because cadmium is a heavy metal and toxic heavy metal. Due to the reason, we should never be opened or put into the regular trash after usage of the battery. And the electrochemical reaction of this nickel cadmium battery, we know that nickel is act as a cathode and the cadmium is act as a anode. So the oxidation takes place at the cathode, at anode. The oxidation means the cadmium hydroxide, the nickel oxide, to gain the electrons, is converted to nickel hydroxide and cadmium oxide to release the electrons. And so cadmium hydroxide to release the electrons. The overall potential difference is usually it's happened 1.2 volts. So in between that potential range, the nickel cadmium battery can generate the potential. And another battery, what is the usage of a nickel cadmium battery? The nickel cadmium battery, has a small size and a high rate of the charge-discharge capacity, and which makes very useful for all electrical applications. And it also very low internal resistance. It produces very low internal resistance comparatively other secondary batteries. And wide temperature range, we are utilizing this battery. Up to 70 degrees centigrade, we can utilize the battery. The potential is also very good potential. It can be generated when we are, properly uses the nickel cadmium battery, and has a longer life than sealed storage cell. It has good life, so properly we can seal the battery. So these cells are used in electrical calculators. The secondary battery, especially nickel cadmium battery, we are using in electrical calculators, electronic flash units, and the electrical devices, shavers, transistors, like that. Nickel cadmium cells are widely used in medical instrumentation and in emergency lighting, toys, and etc. Nickel cadmium cells or batteries are widely used in medical instrumentation also. And this also used in aircraft, space shuttle power system. This is also used in aircraft and space shuttle power system. And nickel cadmium batteries are last longer in terms of number of charging discharge capacity cycles have, and then rechargeable batteries, then other rechargeable batteries. So these batteries have good recycling capacity comparatively other secondary batteries, other rechargeable batteries. So that's why the batteries have long life. And nickel cadmium batteries have much higher energy efficiency. Is a good energy efficiency of this battery. So that's why nickel cadmium batteries still we are using. But the only limitation is the cadmium has heavy toxic metal. So that's the reason we are avoiding the nickel cadmium battery nowadays. And what are the differences in between the primary secondary batteries? After discussion of primary batteries and secondary batteries, so what are the main differences we are identified in between the primary and the secondary batteries? So differences of primary and secondary batteries. The primary batteries means those batteries are non-rechargeable batteries. It means we are going to use single usage and to be discarded after usage. Those batteries were called as the primary batteries. So primary batteries are non-rechargeable batteries. Primary batteries are non-rechargeable batteries. That non-rechargeable batteries were considered as the primary batteries. Secondary batteries means the rechargeable batteries. Which batteries are rechargeable capacity have, those batteries were considered as a secondary batteries. It means that batteries multi-cycle usage. With the primary batteries are single use because single cycle is happened. But here the multi-cycle uses charging, discharging capacity there. So that's the reason we can use the multi-cycle. The cell reaction in the primary battery, the cell reaction is irreversible cell reaction. Irreversible cell reaction. The cell reaction is irreversible because it means the cell reaction is not reversible cell reaction. The cell reaction is not reversible cell reaction. So it means irreversible reaction is happened in the primary battery. The cell reaction is reversible cell reaction. A reversible cell reaction. So in the secondary batteries, the cell reaction is reversible cell reaction. It means it cannot rechargeable that batteries because the cell reaction is not reversible. That means cannot be rechargeable these primary batteries. But secondary batteries, we can rechargeable these batteries. And primary batteries, it is very less expensive. And the secondary batteries is comparatively primary batteries is very expensive. And we can use this as long as the material are active in their composition. The material is very active. So charging and discharging time, that materials we are going to use in the use. And it can be used again by recharging the cell. We can use this battery, again by recharging the cell. But the primary batteries, it depends on the material in the presence of in the cell, how much electrochemical reaction would happen in the cell. So, but then compared to secondary cell is going to again we can recharge the battery. We can recharge the cell. The primary batteries, the best example is Leclanche cell or lithium cells. This is the primary battery example. We already discussed dry cell, that is an Leclanche battery, and mercury cell. And these are the primary batteries example. And the secondary battery example, that is a lead acid battery, nickel cadmium battery. So zinc also alternative one of the material, biocompatible material that also we are using. And the nickel metallic carbon battery, alkaline batteries also we are using nowadays, the secondary batteries. So these are the secondary battery examples: nickel cadmium battery, lead acid battery. So this is the differences in between the primary and the secondary batteries. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.